you just go. So so hopefully it wasn't too complicated, or shouldn't be too complicated. If you do your research and you wrote your paper, then it should just be kind of just talking about your research. That's it. Okay, so we're scheduled to start based on my, like I say, based on the schedule that I have. The first presentation it starts in 10 minutes. So we have a few minutes if any of you have any questions about anything. The last thing I want to tell you, I guess, since you have a few minutes, since nobody else decided to present today, is that if you do not have a chance to present this week, we still have all next week. But academically speaking, academically wise, everything should be completed by this Friday. Okay, I am going to finalize most of you guys' grade by Friday. Seniors, I have no choice. Seniors, your grade will be finalized this Friday. The rest of you, academic-wise, the only thing that you need to submit is your paper. That's the academic. That's the work for it. So that's the one that counts the most. If you do both the paper and the presentations, I am going to give you 5% towards your grade. If you just turn the paper alone, if you don't get 2%, I'll give you 4%. Okay, I'll give you 1% for the presentation. And of course, I don't know if the 1% is going to make a huge difference, but as long as you're turning your paper, which is the big thing, that's the one that matters, and that needs to be completed, or that should be completed by now. But I know some of you guys asked for extension, so I'm hoping to be able to done with your final grade by Friday. So the presentations, we can push it up to next week. No, I don't have no problem. So just FYI, just in case you didn't have room for this week. But again, if you want to get out of the way this week, then you're done. And literally, basically, what I'm telling you is that if you present, you're turning your paper and you present, you're done. You're done for my class. We're done for the year. There's nothing else you can, that you need to do. And then that's it. That's the end of the year. Again, I want to apologize about what happened on Friday. And to be honest, my baby was not having a good weekend. She was very clingy this weekend. So I didn't really had a chance to finish the lesson. But then I was thinking about it. I'm like, well, I don't know if there's really much point to continue finishing the new concepts and ideas if we're really not going to practice, or we're not going to do anything. It's not going to really count much towards your grade anyway. So if we finish early, produce early, next week, if you guys are bored and you're like, I need to do something, I'll be more than happy to host a few meetings and then talk about it. But guys, we're not going anywhere. We're going to be stuck at home for a while, especially nowadays. Please stay safe. Don't go anywhere else. It's kind of crazy out there. And just stay home. And if we need to talk about some stuff, then we can go from there. Just very quickly, it's when you think that things can get any worse, bam, right? This happens. So, but look, guys, my only thoughts and the only thing that I want to tell you about this whole situation is that it just doesn't make sense to excuse wrong with more wrong. And it's very sad that that we're going through this. And I've been seeing a lot of posts, a lot of people saying how how everything that is happening right now is justifiable because of everything that happened, and yada yada. Everybody's putting all these quotes and all these messages about, oh, if you do care about the riots, but you didn't care about what happened, then what to say about you? Like, you know what? At the end of the day, I feel that it just comes down to understanding the system. There's a lot of issues, a lot of problems in this country. There's no denying it. However, the only way that you're gonna be able to tackle and battle those issues is if you go to the source. There are rules, there are laws, there are systems in place that were created. And unless you want to see a change, you need to educate yourself and go to the source and do it. But you going out there and breaking stuff, stealing stuff is not gonna solve anything. It's not gonna do anything. Yeah, you might bring you might bring the attention and try to whatever. But there's other ways to do this in a more civilized manner. But again, unfortunately, the way the situation is right now, it really goes to show you that the desperate times that we're living on right now. A lot of people that are doing this. Maybe there's people that are doing it for just to do it, just to do the wrong. But I think that in some sense, there's people that actually do it because of necessity, right? And that goes to show you that there's a huge divide between the majority and the minority, and that there's a lot of inequalities in terms of the resources, in terms of the options and things that we have access to. But again, I have always mentioned that your worst enemy will be ignorance. So please make sure that you educate yourself. You understand how the system is laid out, so that you have a better chance to fight it, understand it, and make better judgment in terms of how you want to go about making your case or raising your voice. Because there's definitely many ways of doing and going about it. And definitely going out there and trying to take something that doesn't belong to you, or just stealing and doing stuff is not, I don't think it's not the right way to do it, but it is what it is. Anyways, I hate politics, but it's not easy. It's difficult not to listen and see that the craziness of what's happening outside. But the only thing I can tell you guys, please stay safe, stay home. I don't know if you got my message. Do not go to Franklin today. Franklin is closed today due to this whole thing. They want to make sure that people stay in place and just kind of continue being safe. The coronavirus has not gone. Okay, it's still there. It's just interesting to see all these people running together, and and some of them not even wearing a mask. And so I don't know. Let's see in 2 weeks, how the hospitals look again, and we'll see. But anyways, enough of that politics stuff. Enough for us. So, Martin, I honestly feel that this is not going to take any longer than a day or two. I think as far as graduation and everything for you guys, it's still scheduled as normal. Friday is happening. And honestly, Martin, for you seniors, from on honesty, guys, I am so sorry that this year has been so chaotic. And it has taken so much from this special year. I know it's going to be definitely one to remember, and I hope that you take all of this as a learning experience. I think I asked you guys at the beginning of the year. I asked if being in quarantine really, or what did you learn about yourself now that you're in quarantine. I hope that some of you guys really took this time to reflect and really think about, what is it that you're good at that you didn't know before? Because I guarantee you that even in the desperate times, even in the hardest times, you will always find something positive to look up to, and if you always hold on into those little things, I think you're gonna be fine. So don't let it discourage you to continue, keep fighting, keep doing, stay positive, stay in good spirit, fight on, always fight on, and you guys gonna be okay. So anyway, with that, I am going to open up for whoever signed up first, and that would be Marinela and Daisy. If you guys are ready, you guys you have access to share your screen. If you guys want to go ahead, and honestly, there's 2 groups presented today. I have Marinela, Daisy, I have Matthew, and then I have Martin and Ty. So the order, it doesn't matter. So whoever wants to go first, I guess it doesn't really make a difference. You're still gonna go today anyway, so you should be ready. So any takers, anybody who wants to go first, and then after these 3 groups go, if there's time after that, if any of you guys want to go and just get out of the way, I'll be more than happy to go. Cool. Awesome. Okay. So, Daisy, Marinella, you guys ready? You guys in a minute?
Sure.
All right, awesome. So you have actually, so you're able to share your screen. If you just open your presentation, share your screen, and then whenever you're ready, just start talking, and we'll listen.
Oh, Marinella's gonna share it.
All right. Okay, no rush. We have plenty of time. I mean, not a lot of time, but we have a few minutes. For the future, if any of you guys would like for me to run the presentation for you, again, just if you guys want me to run it for you, I'll be more than happy to do it. Let me see. Schoology. And again, as long as you give it to me, just to make it easy, just give me the link through Schoology.
Mr.
Yes, ma'am.
That's not working, so I'm just gonna send it to you through Schoology.
Yes, please, because that would be the easiest thing. Just show me the link. Just give me the link and make sure that you give me permission to access, or just when you copy the link so that anybody with the link can share it, and then I can do it for you guys. Let me open my Schoology. Ty, if you can just send it through Schoology, it will be easier for me to, let me see. No, that's not it. Schoology, where are you? Messages, here it is. Refresh. Oh, there it is. Okay, Daisy, I just requested permission, so if you can just give me permission to see it, that'd be great. Did you get my request?
Yeah.
All right, just say yes, give me access, and then I will be able to open it. Okay, Ty, if you compose a new email on Schoology, just copy and paste the link, and I should be able to open it. Daisy, or if you can't, because I haven't gotten your request, another thing that you can do is I am going to post my email. Just add the email in that. Damn it. Just add that email to that who can see it, and then I should be able to. Okay, hold on, let me see. Perfect. It works. All right, Martin and Ty, I got you guys', and it's working fine. Ooh, fancy. Okay, so.
Should we go first?
No, Daisy's gonna go first. You guys can go next, and then we can come back to you. Okay, Matthew. Okay, all right, Daisy. So here is your presentation. Okay, and then you just tell me when you want me to go to the next slide, okay? All right, guys, with further ado, here is Manila and Daisy talking about general relativity. All right, girls, take it away.
Okay, so basically our question was, how did general relativity come to be and why is it relevant to this day? So the central point of the theory is the principle of general relativity, which states that all observers, no matter their state of motion, will see the same laws of physics operating in the universe. So Einstein states that there is no force of gravity. It's just the result of our planet free falling through curves, space times around the sun. Marinella.
She said to give her a minute. She'll be back. I love this show, by the way.
She said she got disconnected turning on the mic. So
Okay, let me see. Let me see if I can let her back in. Hold on. Oh, there she is. She's coming back online.
Hi, sorry I got disconnected. So, Albert's
Hold on.
visualization.
Hold on. Let me just get back to what happened? Did I? No, no, come back. Okay, there. Sorry.
Okay, so Albert Einstein famously used the thought experiments devised in his mind only to contemplate complex ideas. After his theory of special relativity in 1905, Albert Einstein envisioned an individual who was falling off the roof of a building and then falling downward. This was known as Einstein's happiest thought of his life. He realized that as an individual is falling, they don't feel their own weight. They feel weightless because they are falling with the force of gravity. They are no longer pushing down on the scale and they are falling with it. And therefore, they are in free fall. By going into free fall, gravity could be eliminated. Such a thought cleared up the confusion and complexity of special theory of relativity that only worked for circumstances when things move at constant speeds through the universe. Einstein was able to envision a universe where gravity was not a force, but a geometric property of curved spacetime warped around massive objects. That was the beginning of general relativity. Einstein realized that massive objects cause a distortion in space-time. In other words, bigger objects, rather like the sun, warp space around objects just like the Earth. This can be why the Earth orbits around the sun rather than flying out of the system in a straight path. Newton concluded that Earth's movement was thanks to the force of gravity. But Einstein's theory states that there is no force of gravity. It's just the result of our planet freely falling through curved spacetime around the sun. Therefore, the reason why gravity is called a force caused us to question what caused Albert Einstein to change his perception of gravity, and thus resulting with the theory of general relativity.
Okay, well, since the theory was first published, it has been tried on various occasions within our solar system. Among the many studies, these are like three that are, I guess, some of the most popular studies that support the theory of general relativity, which is Mercury's precession, gravitational waves, and gravitational redshift, but I'm only going to discuss the Mercury's precession. Since Mercury orbits closest to the sun, it is therefore the most affected by the space-time distortion that's created by the mass of the sun. And every time Mercury completes its elliptical orbit, it does not like precisely return to its same location. Rather, the ellipse gradually rotates in space, such that the perihelion moves to a moderately different angle within an orbit. The theory of general relativity gave the proper orbit to the perihelion shift, since Newton's law of gravity couldn't.
General relativity, a groundbreaking theory by Albert Einstein that predicted the precession of Mercury, gravitational redshifting of light, gravitational waves, and others. The theory has proven to be successful and such, but incompatible with quantum mechanics in explaining the gravity in a black hole. Quantum mechanics is incompatible with the theory of general relativity because in the quantum field theory, forces act locally and through the exchange of well-defined quanta. In other words, general relativity requires the gravitational fields to be endless to be true. Though in quantum mechanics, such gravitational fields are defined as limited to allow the idea of forces occurring locally. Even so, the main focus is why general relativity is important. Well, due to the theory of general relativity, our smartphones and GPS systems are able to accurately pinpoint a location. The GPS satellite clocks in space would be 38 microseconds faster compared to clocks on Earth if the theories of special and general relativity were not applied. Therefore, though the theory of general relativity may not be consistent with new findings and discoveries, it has proved to be an incredible breakthrough in modern science and predicted black holes and gravity waves before being discovered.
That was awesome. Does any of you have any questions about the? Wait, I'm sorry, girls, are you done?
Yeah.
Mm-hmm.
Any questions for these ladies? Guys, just very briefly, I just wanted to know, I want you guys to kind of understand that you guys are in a time where even though craziness is happening, all these awesome stuff are also happening at the same time. For those of you who had a chance to see the launch of Dragon or SpaceX into the International Space Station, this is the beginning of an entire new era of space travel. This was a commercial kind of trip to the space station. And this is exactly the beginning of how it is going to, this is the beginning of space travel as we know it. This mission was on its own kind of historic, but at the same really awesome because I encourage you guys to really look at the difference between the capsule that was used in the past to the one that it was used this time. And you're going to see a huge difference. Somebody sent me a message this weekend and told me, hey, Cruz, you said that in order for you to be an astronaut, you're supposed to have 20/20 vision. And you can't wear glasses. But yet, one of the astronauts that was in this Dragon was wearing glasses. Well, if you look at the space at the capsule, where the astronauts were being, where the capsule were in, the controls in the capsule were like a screen. And if you look into one in the past, it's full of gadgets and full of buttons that it require you to be, have all these senses 100%. Otherwise, keeping track of everything, it was very difficult. So I don't know if you guys really appreciate it, if you saw it, if you witnessed it, but it's just the simple fact that we were able to launch a people into space using a commercial private rocket. It's just that's it. It's all down here from now. It won't be long before the next cruise is going to be a 20-day trip around the moon and yada yada, instead of going to the Bahamas or whatever. So it's changing very rapidly, and the ship and the rocket that went into space, it's kind of looking very similar to the ships that you see in a bunch of sci movies, sci-fi movies, of how we actually get into space. So really cool stuff. And special relativity definitely, well, it doesn't have a lot of influence in this, but it's definitely it's part of this, because special relativity does account for some of the discrepancies in time and how to be communicating in space and how you move. So really cool stuff. Anyway, awesome. All right, Martin or Matthew, any of you guys have a preference? Who wants to go first?
Oh, cruise. We signed up for 12.
Okay, fine. Let's do it. Sorry, Matthew.
Cruise.
I talked too much. So we have plenty of time. You can go. Okay, guys. Do you want me to share the presentation, or you guys want to do it yourselves?
We shared it
You
too,
can share
so
it.
you can share it.
I can share it. I have it ready. Bam. All right. Thank you, ladies, again. That was awesome. It's pretty cool. I really like your presentation.
Thank you.
Yes, Matthew. Sorry, you just go next. All right, here we go. All right, guys. Whenever you guys are ready, and just let me know when you want me to switch the when you want me to go to the next slide. Go.
So our topic was supernova, or in like plural tense, supernovae. I think that's how you say it. Kind of like goose and geese or whatever. So you can go to the next slide. Oh, so our focus question was, are there any benefits to supernova, and things we focus on are what stars produce in their lifetime, what happens when a star is at the end of its lifetime, and we compare volcanoes like destructive power to a supernova. Yeah. So this raised the question, could supernova have benefits despite their destructive power? Next slide. So supernova are what happened at the end of a star's lifespan. So essentially what happens is that like the star's core collapses, and it happens in like a matter of seconds, and because it's like a nuclear core, it has like a very massive explosion. And this, well, for me, like it raised the question, like, so volcanoes are kind of the same, like how they erupt, but I've also heard that there's like many benefits to a volcano. So they provide benefits to the soil, they cool down the atmosphere, but not like a lot, but they cool it down by like a couple degrees or whatever. And they also contribute to oceans. So like even though when they erupt, like volcanic, like the lava kind of like creates like ash and burns everything like around it, it provides like a lot of benefits, well, some benefits to the world. So so we were kind of wondering, could supernova be the same? Next slide. So at the beginning of stars, they start out with this cloud that's called an Orion nebula. So what happens is that gravity kind of brings it together and creates a core. So yeah, it collapses due to gravity and turns it into a core, and which creates a nuclear fusion of hydrogen and helium. So at the core of a of a star, like at the beginning of its lifespan, is I guess like a helium core and then a hydrogen fusion outer core. And over the span of a star's lifetime, uh, the hydrogen fusion outer core collapses and it creates a red giant. Um, there's like a diagram. So then they and then as they grow and as they become older, they create like a carbon, oxygen, neon, and magnesium silicone layer. So there's like a picture with all of their layers. And then as they get bigger, the shorter lifespan they have because they're using all their energy, I guess. So yeah, so when they become like a super giant or just really big, they get so heavy that they carry elements as heavy as iron. So yeah, next slide.
So there are two types of supernovas. The first one being a binary star system, which is pretty much like a white dwarf. It's when a white dwarf star gets too close to a companion star, and it pretty much sucks the energy out of the other star, and it could the energy goes from the other star to like the white dwarf, and the white dwarf accumulates too much matter and it explodes like due to being able to like uphold itself. Our cruise, you could go to the next slide. And then the type 2 supernova is pretty much just like it's so a star has gravity. Gravity pushes a star together. Like it tries to keep itself in like a tight ball, as dense as possible, and the energy of the star's nucleus creates like a strong outward energy, and the outward push resists the inward squeeze of gravity. And with these two forces pushing off each other, the nuclear core burns and then stops the causing, and it stops the inward gravity, and pretty much like the core loses energy, so gravity just makes like the star like explode and collapse within itself. And when a supernova occurs, it is like a very very powerful explosion. So this could send like particles and like elements and particles and atoms and stuff flying like really fast, really high speeds, going across the universe. And then the chart that we have below, you could see elements like that like are known to come from a supernova that we have on Earth. All right, Chris, you go to the next slide. So in conclusion, pretty much a supernova is the death of a star, and throughout a star's lifespan, it could be creating new elements. And when a star collapses, it can cause elements and particles to spread. And with that happening, black holes can also be created too. And that's pretty much it.
Their explosions are so like huge and like massive and just destructive that it could like rip space and create a black hole. So that's cool. So whoever has that, thanks to supernovas.
Yeah, so that saying "you are made out of stardust" is literally true. You are literally made out of stardust, and you all came from the remnants of a supernova explosion. So it's kind of crazy that such an event. And by the way, recently there was a supernova explosion. I mean, when I mean recently, about a couple, I think over 50 years ago, 100 years ago, or so, I forget exactly when. There was a supernova explosion, and they're so powerful and so bright that you see them. You see them in the sky. They're very bright, and throughout history, there's been a lot of civilizations and cultures that have recorded this type of explosions, and and it's so they do happen. Obviously, with the current technology, it's more easier to find them out in space, but sometimes they're visible with the naked eye. You could just see a bright spot in the sky, and it just it's just like a star bigger and brighter than normal. But but this is one of the things that are pretty cool. And yeah, space is awesome. This is again a whole branch of science. It's called cosmology. This was what my focus was. I for Daisy and Marina's presentation, I actually did my comps or my final project or my senior year comps in gravitational waves, and we come a long way to understand space itself and how everything works. So it's really cool stuff. And I think that you guys made an awesome analogy based on here on Earth, right? We always have, think of all these phenomena as being destructive forces, but if you really, really understand the mechanics and everything, you find out very quickly that some of these destructive events are actually pretty crucial to the survival and the ecosystems that we have right now are due to those phenomena. So yeah, so it's pretty cool. It's kind of cool to for you guys to kind of learn kind of this topic, so at least you have a sense of what really is going on and how how we got to be here, how we got, how do we become us, and obviously the question of evolution in humans is it's a little bit more complicated than that, but understanding some of these fundamentals about where we come from and how things became in the universe is actually pretty cool, and it gives you a sense about the normans, the normany of the kind of the big things that happen out in space that, even though they're pretty destructive and very powerful, they still contribute a lot to our survival. So pretty cool stuff. Any questions for these guys? Awesome. Thank you, guys.
No problem, Cruz. Anything for you, man.
Yes, sir.
No, anything for you. Anything for you. Cool. Awesome. So there's no questions. We have one more presentation for today. And I think that we'll have just time for that more. Again, if you sign up for Wednesday, and if I'm not mistaken, for tomorrow, I have 1, 2, 3, 4, 5. I have all 5 full. Just make sure that you're ready to go. And if anybody want to be in standby, if you want to get out of the way, please let me know. And then if you have time tomorrow, we can definitely try to squeeze you in and just get out of the way. And the same thing goes for Friday. Everything else, we just kind of move forward. We'll kind of push it for next week. I will resend the link on Friday again, so that people can sign up once again. So some of you guys have been texting me saying that there's no more time slots or you can't sign up anymore. It's because, I was able to create this Google Forms to once the time slot is picked, then it takes it away from the options. So once all the spots are taken, then there's no more options. That means that everything's taken. So just just FYI. All right, Matthew, do you want me, do you want to share your own screen, or do you want me to run it for you?
Let me just try and see if I can share it real quick.
Cool.
Okay.
Awesome. All right,
So,
Matthew.
sorry.
Sorry. Let me just. All right.
Okay. So I did my research question. I researched planetary accretion. Sorry, hold on. Okay. My question was, I asked, how does it work and which one is most likely true? Now, even though this is such a large basis for how our solar system is, it still hasn't been answered to how planets are actually created. Some possible models or theories for this are the pebble accretion model, the core accretion model, and the disk instability model. Now, one major prerequisite for all this is the accretion disk. Now, it provides a basic environment for the planets to be, I should say. So the accretion disk is mainly gas, so 99% gas and 1% other material, usually in the form of dust. The lifespan of the disk is from about 1 to 10 million years, and usually at the center, it's a star of some type. Now, for our first model, it's the pebble accretion model. This one is the most recent model, I should say, which was in 2014 by Michael Lamberts and Anders Johansson. And pretty much how it works is pebbles float around in space and clump together. And that this happens over a fast period of time where it just keeps on collecting, or accreting, I should say. And this helps explain also how gas giants form as ice giants, so Jupiter, all them. And, yeah. Our next model is the core accretion model. This is the most commonly accepted model as of now, and it was first proposed by Viktor Safronov in 1969. Now, this is very similar to the pebble accretion model, but this is more gravity-based in a sense, because clumps of matter collide, and these gravitational field keeps growing and growing, allowing for a wider net, in a sense, for more material to collect. And this keeps on happening until a planet is later formed. And for the last model is the disk instability model. This is probably the least popular, well, not least popular, as the pebble accretion model is the most recent and has yet to gain as much of a following as the rest. But this was probably the first one proposed out of all three that I'm discussing today. It was first proposed by Gerard Cooper. I believe I'm saying that right, in 1951. Pretty much how this works is material in the disk ends up compounding into fragments. It ends up condensing over time. And this only happens during times of rapid cooling. So it's very specific in how it's done. Condensation ends up occurring until a planet is formed, so it keeps on happening over time. Now, sorry, one second. Okay, so pretty much these are all viable options, and as I said before, there is no definitive answer as of now to how planets are formed, but what I believe to be the most probable scenario is the pebble accretion model. I believe this is the case because it allows for fast planetary formation, which is needed to fit within the lifespan of the disk. Now, although 10 million sounds like a long time, the average span of an accretion disk tends to be about 2 million years, which may not sound like a lot, but take, for instance, the amount of planets that we have in our solar system. All those planets need to be able to be formed, in a sense, in that around time slot. Not to mention the fact that they have to be formed far away from the star. So that's also another thing that needs to be sort of like a requirement. And it also has a high likelihood of occurring, which can explain, the size of larger solar systems such as our own and others out there. Yeah. Any questions?
Anybody have any questions for Matthew?
Oh, what do they look like?
The accretion disks? Or,
Yeah, all of them. Like the different models and stuff.
Okay, well, the pebble accretion model, well, this is the accretion disk as of here. It pretty much has the star lining up in the center of the disk and is mostly comprised of gases, I had said before. Now, the pebble accretion model, if you think about it like this, as pebbles, they're small centimeters to maybe a couple meters wide. So they're not very big. They end up forming into bigger and bigger clumps known as planetesimals, and later growing into bigger sort of planetary cores or planetary embryos, as they call them. And then they just keep growing. Core accretion, it pretty much just relies on material just colliding, I should say, and until it's done. And then disk instability, I couldn't really grasp how it really looks. But if you think about it as material keep condensing, or how would I say this?
Well,
Yeah.
I can help you with this one. So, so remember that one of the things that we learned a while back with universal law of gravitation is that absolutely everything has matter, and this matter right here, by the way, it ties nicely to what you guys talked about with supernova explosions, because supernova explosions, when they explode, they disperse all these heavy elements and materials into space. So some of these materials get trapped into these clouds or planetary accretions, where some of the heavy elements start attracting the light elements, and this is just to gravity. Again, one way to think of this is just Newtonian way, which is there's a force of gravity between two objects that has mass. But if you want to talk about special relativity, each little pebble or each little mass is creating this void that makes things kind of fall into each other. So if you want to talk about Newtonian way, then yeah, then you get all these chunks of matter that are attracting other chunks of matter, and eventually they get big enough to become a planet. And this is why most planets, especially the rocky planets, at the core is like the heavy elements, right? Like iron and nickel and all those heavy elements, versus some of the lighter planets where everything is pretty much gas, because the way they were able to attract and kind of keep these elements combined. But if you if you really want to kind of go either way, like if you want to talk about special relativity, then yes, each mass or each kind of chunk of matter that is coming together, they create a kind of void, and things are just falling into. And as they fall into, they start compressing and creating chunks. And this is the same idea. I don't know if you've done like if you throw dirt or you throw anything into water, and eventually it starts getting to the floor and it starts kind of compacting because of this pressure. So same idea, right? That you start putting stuff together, things are kind of like by on pressure, kind of starting together, kind of clumping. But if you want to think in terms of F equals ma, or just Newton's laws, yeah, there's this gravitational pull, that things that are pulling stuff together, and then therefore you start, combine all these particles, and eventually they grow big enough to become planets. So yeah, but accretion, planet accretion is pretty cool, because ultimately answering the big question, how did the universe, or how our our solar system came about, and especially nowadays that scientists are finding new solar systems, and some look really, really different, and some of them are looking very similar to ours, but we finding out that yeah, this approach, or these ideas of how planets are created, or how solar systems are created, it's not 100% validated yet, because we're finding new solar systems, we're finding new planets that defy the laws, define how our solar system is created. And the thing is, if you think about it, everything that we understand, everything that we know is based on what we have access to. We're able to see our solar system, so we assume that everything that we kind of want to know about a solar system is based on what we have knowledge of. But then once we start reaching out to other areas of the universe, we're finding out that no, we're not the only solar system, and we're not the only way of we're not the only form of solar systems, how solar systems can be created. There's all these different models and planets that are being discovered on a daily basis, or on a regular basis, that are really defy some of these questions. So again, one of the things that we talked early on in physics is that there's a huge difference between a law and a theory. And some of these are theory because we continue finding new systems, finding new approaches and new ways of understanding how these planets were created. And until we find a concrete system that we know is exactly how things work, then we'll call it a law or something. But now there's a lot of stuff that are theories out there that they still need to be proven in order to become a law. But it's really cool. It's really interesting to kind of know exactly how things outside the universe also behave. But again, we live in a very small planet, relatively small compared to other planets, and almost every week, NASA or JPL or some of these astronomers and cosmologists are releasing new data and new information that they're finding planets left and right. I think recently, about 2 weeks ago, I read an article that they found they found one of the most closest planet to Mother Earth. It is on the habitable zone. It's in a solar system that is very similar to us. And unfortunately, it's a couple, 100,000 light years away from us. So we're never going to get there to really know whether or not is it Earth-like and there's life in there. But they're finding solar systems that are very similar to us. So that kind of go in towards just trying to find a model that would fit a specific type of solar system like our own. So pretty good stuff. And I don't know, who knows? This might be important because now that we can go into space, who knows? Maybe next time, we're able to find a way to go and travel at warp speeds and go across galaxies and discover new stuff. And I don't know, make it cool. Anyways, awesome stuff. Well, guys, good stuff. Good way to setting the bar in terms of presentations. Awesome job. I really appreciated your work. This is really cool. And I guess just moving forward for the rest of you who will present on Wednesday and Friday, it's exactly what you need to do. Just get a presentation ready. Just talk about your research, what you found, and then that's it. And then as soon as you finish your presentation, hopefully by the time Friday comes, or when you present within a day or two, I should be able to kind of finalize everything regarding your grade. So any last minute questions, thoughts, suggestions, concerns? We have about 5 more minutes about anything portraying your presentations, your final grade, anything. I'll be more than happy to answer. Otherwise, we'll call it a day. We'll reconvene on Wednesday again to hear some other awesome presentations, and then we'll see. Any other questions, guys?
Cool. So once we present, we're done.
Yeah, you get. We're done. Yeah, you're done for my class.
Nice.
You can. And then so now, and as you present, based on the criteria that I give you for your grade, given that you've done everything like I asked you, I'm just gonna go back and I'm just gonna like add everything. And then once you present, you should be able to see, within a day or two, your final percentage on the final grade column part. And if you've done everything like the criteria I ask you, then it should reflect everything that you did based on that criteria. And then you're done. If there's any questions, you can let me know. We can fix anything. But I think that, most of you guys are I've been doing all your stuff, so I'm not too worried. You guys are fine. Yeah, but after you present, you're done. You're done for my class. Well, given that you turned in your paper, but if you present in them, is that you turned in your paper. So cool. Any questions about anything else? No? Well, what you guys have presented today, thank you so much. I really enjoy your presentations. They're awesome. I guess we'll look forward to Wednesday's presentations, and I'm sure everybody's gonna do a great job. So so just get ready, and I guess I'll see you guys on Wednesday. And then I continue sending me emails and asking me questions about anything, so that we can kind of help you finalize everything for for your grade and everything, hopefully by this week. And don't go to school today. Stay safe. Cool. All right, guys. So it seems that there's no more questions. So please have a wonderful day. Stay safe, and I'll see you guys on Wednesday.